Okay. Thank you, Glenn. I guess the first thing I want to say is why I chose this place. This is the project I'm going to show to you is sort of a, I think of it as a MUSIG, probably the ultimate thing that a MUSIG can do. And that's because it's through associations with people in MUSIG, largely, that this project came about. The other, that'll become clear in a little while, I want to lead up to that. The other interesting part is that the technology that we're really feeding off of, or sort of inheriting, was developed and blessed in this building and lived for a long time in the basement here in the form of the sandbox. So we're sort of in that tradition. All of synthesis is, but I think this project is perhaps a little bit more than others. I want to play just, I do have a synthesizer to show you. I'd like to just play it for you, 4 sequences for you to listen to. And I'd like to we'll play a little game afterwards of, I'd like to get some ideas about how you think it's being done, what sort of level of quality, and so forth. This is a standard Windows computer. Let me see. Okay, let's see, hard rock tune here. That sequence is provided in the standard Windows MIDI test suite, so I can't credit the composer. Pretty darn good though. This is a version of something by goes on. some spectacular sequences that are coming out of these shots now. This is the last one. Listen to the snare drum. Okay. What was that? What was that? I don't know. It's called Stargame Mid. I don't know where. Okay, so let's play Guess the Synthesizer. Anybody got some ideas? Sampling rate? 44.1, 22, 11. Sound card? Hardware? Does anybody want to see what the synthesizer looks physically? What it looks like physically?
Yeah.
Well, floppy disks. The synthesizer runs on the CPU itself. There's no sound hardware. That means that what we can do now is, I don't want to get too dramatic. This is the beginning of the end of hardware synthesis. The Intel CPUs have become so darn powerful that we can do a General MIDI synthesizer in real time. 24 voices, full sampler fidelity, sounds like a sound canvas to most people. And there it is. Look out. Because now, wherever you have a computer, whether it's a laptop, whether it's your watch, your cellular phone, we can give you this. It takes no physical space. It takes a little bit of RAM. That's a picture of the future, and it's kind of interesting. Some of you may have been at the I think it was October '91 meeting where I presented the General MIDI proposal. That was a month that it was finally approved by the JMSC. And I think the spring after that, Avram gave a talk about PC, the music platform for the '90s. And I left Avram's talk. I was going to say, how are we going to pull this out? What is he talking about? I mean, all we have is sound blasters out there. Well, we figured it out. This is how it's going to be done. One thing that's different about this product is that you're not going to be able to go down right now to Fry's and pick it up off the shelf. We have to engineer it right onto the motherboard of the computers because it's sort of an intimate relationship with the output structure. But rest assured, wherever you're going to see now computers where the audio hardware is built right on the motherboard, and the processor itself is going to start sucking up all these functions that you used to have in a sound card. And that's the business we're in right now, sort of putting sound cards to rest. Yeah.
So basically, you will have the sound built into the computer. You don't need a sound, audio.
No more sound card. No more sound card. Yes.
What hardware is necessary on the motherboard?
Okay, I'll go through a bunch of this stuff. I have this is the outline of what I want to talk about. So let me get through some of these points, and then let's take up some of these questions in an orderly fashion. We'll get the information out pretty efficiently. Okay, what is it? We played that. In other words, what does it do? What is it? Okay, we covered that. History. Well, I sort of covered that. System requirements. Okay, first, for hardware, you need an Intel CPU. This will play on 25 to 66 megahertz systems. System requirements. Memory, I don't know. Some people think you can get by with 4 megabytes for Windows. I don't particularly. 8 is pretty minimal. 16 is really recommended. Up from that is personal choice. System requirement, that's in terms of hardware. In terms of software, Windows 3.1 on DOS 5.0. That's fine. Let's see. The function of the synthesizer, which matters. This is not a lot of news here, but it looks like this for those of you who need a refresher. We're talking about this drawing. Basic function of the synthesizer really only has one function. That's to get MIDI calls in Windows and convert them to stereo GM audio. And once you install the synthesizer this is always try to orient you a little bit to what it actually is and where it sits inside the machine. Statistics say that 9 out of 10 of you have Windows machines now as opposed to Macintoshes, but for those of you who haven't seen the Windows driver system, when you install all your multimedia whatnot, they appear in the drivers, installed drivers box here. And you can see Source System Software Synthesizer is there. What our drive is a driver then, it's an installable driver. And what it looks like to the system, it looks like a piece of hardware. It's a piece of software that emulates hardware. As far as the system knows, it's sending data out the MPU 401 back port. It doesn't really care. As you know, or may or may not know, one of the things that Windows does for you is it acts as an intermediary between all of your applications and all of your devices, so that unlike DOS, excuse me, in a DOS application, each application has its own set of drivers. Well, if you just make one set of drivers for Windows, then all the applications can write their MIDI requests to Windows, and then Windows just takes care of it for you. So that's how we're managing it. We're a single Windows driver. Now, the implication of that is that we don't run in DOS right now. As far as DOS in Windows, there's some contention problems there. There's not really a compelling need for that just yet, we don't think. So when you install the synthesizer with your 2 discs, or actually, of course, it'll come pre-installed on your laptop. And think of this, the power of this synthesizer on a little laptop. You'll be able to sit under a tree with headphones, compose in complete CD fidelity. I think it's pretty staggering, frankly. Once you select your driver and you hit the setup button, you'll get your control box here, and I'll talk about this box in a minute. Let me see this here. Input, output, GM compatible fidelity. Right. This box, I think you heard it, and we're going to hear it again. I want to show you some things about loading. For most people, as I say, it's 90%. 90% of people will say it's identical to a sound canvas. And of course, if you want to compare it to Sound Blaster, there's no comparison at all. So, you have to decide with yourself what the price of software is. One thing's for sure, it's going to be a lot less than the price of $400 or $500 GM module. Yeah.
So with Sound Canvas, I can modify the sounds. Can you modify the sounds that you put in?
Yeah. We have a librarian editor, which is available, but that's going to be only available right now to game manufacturers. It's by the time that the product gets to the user on the shelf, shrink wrap and fries, yeah, I think you will be able to. We'll have an editor. Jumping around a little bit here, the distribution of the product at the retail level will be handled by Turtle Beach.
Is that why they're discontinuing their multi-sound card?
No, the multi-sound, they've introduced a bunch of cost-reduced multi-sounds that are very high-performing, Maui and Monterey.
But I heard Monterey's not as good as multi-sound.
Well, we, frankly, well, yeah, I mean, that's true, but the other thing I could say about that is that we demo this A/B, this thing, against the Maui, and actually we outperform it. In very many areas, because this is going to be surprising to you, because you may be surprised when I tell you that this machine is actually running at 22 kilohertz. To most people, it sounds like 44. And if you A/B this against the canvas, and I just didn't want to bring all the paraphernalia needed to do that, you'll hear that in very many cases we're very bright, because even though the sound canvas operates at 44 kilohertz nominally, it has some frequency-dependent compression, which shows up in much reduced ranges in terms of actual playability. So we are brighter than a lot of synthesizers out there because we're not screwing around with the sound. One of the reasons, the heritage on this instrument, Stanley and Leslie Smith, is out of sequential circuits. And we almost always use linear interpolation and linear pitch shifting, and we very rarely screw around with sound. And that's one of the reasons it sounds decent. Where are we now? Let's installation. Okay, you install it. Comes on floppy. There are two sound sets. There's a 2 megabyte sound set and a half megabyte sound set. And when you install, you can pick one or the other or none. It's just kind of pointless. So it'll take 2.5 megabytes on your hard disk if you want all the options. That's sort of, that's not very much. You don't have to have the half, you don't have to have the 2 if you're in tight situations. So that leads into the first issue of sound memory scaling. Because we were starting from scratch, we wanted a synthesizer where we could just sort of bend and stretch it in all sorts of different ways. The first way we do that is it's totally generalized with regards to the amount of sound that we can employ, the size of the sound library. It's totally generalized with regards to the amount of synthesis that we can perform. Inside the synthesizer, there are things called voices, which are based on software algorithms. We have a huge voice table. We have 128 types of voices that we can plug in. And what we do is we use different kind of voices for different purposes. And we change these things around dynamically, and that's one of the things that makes it very efficient. Polyphony scaling. Inside the synthesizer senses how well the CPU is doing, playing the music that is being asked of it. And it looks at a slider inside the control panel. CPU loading. That limits the drag or the load that the synthesizer will put on the CPU. When you center it, that means no more than 50% of the CPU can be devoted to music. And you'll see that degradation, if you want to consider a degradation, in a reduction of polyphony. What's very interesting is that in almost all the sequences, you can get the slider down to 40% or 30%. You won't hear any. You don't really start to hear stealing until you get it down there. This is also one of the things that will be sort of, this control panel is just sort of provisional right now. As we start to package a synthesizer on systems, we're going to be able to control these things remotely. For example, the CPU loading can be programmed from a MIDI file. That's one thing I want to do. In fact, the whole setup, the whole software setup, all the attributes, anything that you want to define in terms of the synthesizer can all be controlled over software, of course. Down here, this destination box here, that happens to be set. You have in an audio, what happens if you have several sound cards? You need to select which one you want to play out of. So that's how you do that. And we can program your output as well.
So could you just go a little more over that? What you just said, if you already have a sound card, you're saying you're cooperating with that. You can,
That's right.
You can make use of it still, even though.
So let's say you have a blaster, 16-bit blaster, FM, good for killing aliens. It's not especially good for listening to music. It makes your ears want to pop off and run out the door. All right, when you pick up Satie in its retail version and install it on your system, and we play you GM quality music out of your blaster. So, some of you may know that there's a Wave Blaster upgrade available for Sound Blaster cards. It's called a Wave Blaster. It's $149. So we essentially are providing that function for you.
The software is going to be retailed. It's called Satie.
That's the research name, really. It'll come out under any number of variety of ways.
So those of us who already have computers are not going to be out of luck, even though we don't have this special motherboard.
No, because there are 10 million blasters out there.
Oh, so you will have to have a sound card.
Yeah, well, somewhere along the lines there has to be an audio output port, whether it's built onto the motherboard or whether it's a sound card, whatever it is. And we have a different strategy for dealing with each of those scenarios.
Are you playing out as though you were playing WAV files?
Yes.
Is that the idea?
Yeah, well, there are a couple different strategies. There's a real generalized approach, which is not really giving us the performance that we want. We want to get down a little bit lower, and we're actually cooperating with Creative on this. You can write up to the system level and appear as if you're a lengthy beat, but that gets Windows involved in these processes where you really don't want Windows involved. It turns out that we get much better performance by staying close to the hardware and keeping Windows' dirty little hands off of our audio. The windows will be much improved in in Chicago, particularly because what we're doing, we're taking advantage of an area that has been largely unexplored, which is this 32-bit code, 32-bit realm. There's a lot of 16-bit baggage left over, both in Windows 3 and in its DOS base, of course. One of the ways we were able to leapfrog into this sort of realm of performance was through this 32-bit code. And when we get to Chicago, DOS will be now a box inside of Windows. And so we'll be able to run in that situation automatically. Virtualization, there's no competition, there's no contention between DOS and Windows for a device. Loading and load management. Okay, this is an interesting issue. Let's play some more music. A lot of people want to know, well, okay, this all sounds great. What is it costing me? What's it doing to my CPU? And there are two answers to that. There's a short one and a long one. The short one is that for the GM sequences that we've tested, we just got a bunch of them. We haven't been very scientific about this, but it's a bell-shaped curve, as you might expect. And what you'll find, this is a 66, all my figures are going to be based on a 66 megahertz CPU. What you'll find is a range from 8% to, at most, 40%. And that would be the elapsed CPU time over the length of the tune. Now, that sounds like a big number, and that's why I want to give you the long answer too. What does that number really mean? There are two ways to think of loading. One is the absolute load figure. The other way is how do you manage the load? And that in a computer, that's really much more crucial, because the computer has a bunch of power. That's the whole problem. It's sitting there right now, spinning off millions and millions of idle cycles. How do we capture the idle cycles? And that's what we are. That's the technical strategy that we went after. We don't want to sit in front of the cursor. We don't want to interrupt the screen appearance. We want to look for the idle cycles, and we want to capture those and take advantage of those, because that's the only way that people are going to accept this technology. Okay. So, if you'll allow me here to show you the way that was done. Actually, I'll do this this other way. I don't know if you can see or not. Here's a quarter frame animation. And I'm going to start one of these tunes. Which one here? Okay, I'm going to start Pig. Is moving here, it's not changing when we play this. Now this sequence is rated at 37% load. You'd think that'd be pretty heavy. But as you can see, there's no interference here. And also, I can hold off the video entirely by clicking on the screen and the music plays without interruption. There's no glitches. So even the significance of that is that you can go from zero load to full load instantaneously, and there's absolutely no glitching in the music. Now, let's see. If that's not good enough, I'll bring up a full, that was quarter frame. I'm going to bring up a full frame. These are Autodesk Animator animations. So now we have a cat and a reciprocating engine there. This one away. And let's pick salsa. Okay, there you have it. is a 66 megahertz processor. That's a full screen of animation, a quarter screen of animation. And I didn't bring the CD drive, but I could have shown you Quantum Gate, which is the new Media Vision CD with full GM scores. You can have that running in the background. So the power is there. The power there is there today. We can run down onto a 25 megahertz CPU. And of course, when we all start turning in these 386 systems onto Pentiums, we're going to be able to go crazy. Satie will run in the corner of the Pentium and won't even be noticed.
Was it as a DXP or as a
Largely.
Yeah.
Largely.
Yeah, that's really cool.
So have you modified the motherboard of that machine?
Not at all. This is, you can't go down the store and buy one of these, unfortunately. This is an Intel OEM machine. It has a crystal codec on it. And
It's a what?
A codec made by a Crystal company.
What's the bus that you're using?
What's the bus?
The bus.
It's really just emulating the ISO bus.
So what is the time frame we're talking about here to where this will be on the shelf where people can buy it? And where people can buy the
I think it's going to be
special
showing up.
motherboard?
It's going to be showing up in June on the market. And probably showing up in some laptops.
And the motherboard, the special motherboard too?
That's a little bit longer process. But we have Intel's marketing it and ICS is marketing it, so there's a lot of muscle behind it.
What audio output does Laserdisc provide or support? Laserdisc support Soundmaster, Media Vision, Quality Studio. Which ones do you expect to support?
Well, that's largely, this is, what I'm showing you today is the root technology. What you're saying is which ones do we port to? And what we're doing, this is sort of a case-by-case kind of thing. The first thing we want to do is we want to, there's sort of an efficiency in distributing this technology. It's not clear whether it's really efficient to throw it out there to people who have 25 to 33 megahertz CPUs. It's probably more important for us to get this on to people that have really fast CPUs and have Pentiums, and then let the other people get it whenever they want. Or when we can get around to it. I might mention that there's a whole slew of cards on the market based on DSP, DSP multifunction boards. When this project first started, we looked at the DSP situation, and we decided it was transitional, and that's why we're on here. If you have a $700 CPU in your system, or $600, whatever it's going to cost, it's not clear that you want to spend, that the manufacturer wants to spend a lot of money on another little DSP sitting there when we can give them all the functionality in software on that processor itself.
For those of us who already have high-end PCs, what sound card would you recommend? Not necessarily one that would support games, but if you're into music, what is your favorite sound card?
Well, right now,
Right now. I was going to get multi-sound, but then I heard they're discontinuing it, and I don't want to buy something that's not going to be supported anymore.
yeah, the software on that one's a little bit old. I don't know. I would look at the Roland.
Tap
one.
10, that one?
Yeah, that's the most multi. I don't have any personal use with it, but that seems to have a good combination of features. If you're not interested in killing aliens.
Which Roland?
What?
Which Roland?
Tap 10.
Tap 10?
Yeah. Let me see if I have any other points here. Okay, just let me get through the last few then, and then I'll step aside. I talked about the control panel, so we're through that. I should probably mention the team that put this together. Myself, Dave Smith, my old boss, Pleasure to work with us, provide some gray hair. David Roche and Frank Gonzalez did primary coding. David did sample vision, which was part of the Ovaltune package. And Frank Gonzalez worked on some low-level drivers for Apple. Alan Fitzgerald is the sound guy who did the sound design. We all helped finish it, of course. Alan is sound manager for Van Halen and also did the sample set for the PB keyboards. So it's a real good team. We got it done in about 7 months. And lastly, where do we go from here? As I mentioned, the synthesizer is totally flexible. When we first built it, we used 16-bit samples. There was a version, right now we can plug 44 kilohertz samples in, so we can build, just by going away and changing some numbers right now, we can go and give you a 44 kilohertz version of this thing. We picked this sort of this mid-level performance approach because not everybody's going to have the CPU needed to do it. But this is the shape of synthesis, how it's going to happen.
You said you started with 16-bit samples. What are these samples?
These were 8-bit samples. This is all 8-bit audio.
And are these mono samples?
Calculated out to 16. They're mono samples,
And you
but they're
yeah.
pan to a stereo space, just like GM asks for. One of the things that's going to be real interesting for me to personally to look into is what we can do. I mentioned we're changing. I'm going to talk a lot about this, but we changed the voice types. We have sort of grungy voices for the percussion, and then we have high-quality voices for the piano. And we're going to be able to extend that thinking to different types of synthesis technologies. So that right now, so that we don't just use sampling all the time. We can mix in FM if we like to, if we want to, or wave shaping, or anything. It's totally, we can do whatever we want. And we've built that with that in mind. So that's another reason this technology is going to really take off. And then we will be adding some of the features to make us compatible with Roland GS, which it looks like stands a good chance of eclipsing GM right now. And that's about the basics. Any more questions? We'll be happy to.
Yeah, could you say a little bit about the technology that's involved in solid to make this product?
Oh, well, no, again. Now, let me put it this way. The synthesizer itself was only half of the job. The other half was dealing with Windows. And, hello? The other half was dealing with Windows. Yeah, and that's really where the large part of the, because anybody can sit down with DOS. Anybody can sit down with DOS and write a software thing that doesn't have to interact with the real world. But when you're talking about Windows, and it's also was a change for me because I was something that I was sort of an Apple Macintosh lover, and then I got involved. This is one of the reasons they got us involved in this was because we're making the environment a little more Mac-like. And one of the things is switching over to this, I got a much different picture of respect for the installed base, which is really governs a lot of your thinking. It really does, and it's important. It's important. So that's why we made it so you can play down to 25 megahertz. The 25 megahertz processors, it will play.
Let me check.
Oh, I'm sorry. It will also, for that matter, it will play on a 3 and 6.
Let me check my summary with you. This is going to be available in June as a software product that you can then play through, say, a board like the Roland.
It won't be retail in June. It won't be retail in June. It'll be appearing on platforms.
As a software product.
Yeah, it'll be like you'll get your laptop and it'll have this nice synthesizer built in already.
Oh, you mean an Intel product?
Not necessarily Intel.
When will it be available? Okay, I've got a 486 EX266.
Yeah, I would say fall.
But-
If you have a 66 and a blaster, if you want to know when the retail version is going to be available, I would say look for it to fall.
In the fall. What do you think the approximate price would be in the fall?
I cannot predict in the wildest. I haven't a clue.
What the market will pay? What's in a hardware?
Oh yeah, yeah, absolutely.
Dollars.
I mean, it's software. I mean, it's just the price of it is. So it really depends on. It really depends on how many middlemen get their fingers in the pie.
So the first availability will be on the motherboard in a new computer. And then the availability for people that don't want to just replace their computers will be in the fall as a software product.
It'll be in ROM?
No. In the retail version, it'll be just 2 discs. You install it, and the samples go onto your hard drive, and they get loaded when you boot Windows. They go flying in off your hard drive.
Stanley, I use Windows 3.1, and lately I've been seeing all this stuff, Windows for workgroups. What is that? Is that a Microsoft product too?
Yeah, it's a different flavor of Windows. It has a bunch of networking stuff, which
So it's for networks, maybe?
Yeah, except that it has a bunch of stuff, some of the best stuff, earliest finished stuff from NT. And I have WFW on here, and I use it because it has 32-bit disk access, which which is a lot faster than standard Windows diskette.
So you recommend it over Windows 3?
Yeah, it is much faster, it's more stable, the protection between crashed applications is much improved.
So even if you have a standalone system, it's probably worth upgrading to Windows for rooters.
4 out of 5 editors say so.
Well, I noticed like if you buy a gateway now, that comes with it, and if you buy ZOS,
It's a better
it comes
Windows,
with it.
yeah, everybody says it's a better Windows, even if you're not using networks.
Could you run this under Solaris WAPI?
Hello?
Solaris for x86.
Did we write this under this?
No, I said, could that be a host for this software?
Well, I don't know, I'm not familiar with that at all.
It's a kind of Unix that runs on
Yeah, I mean, I don't know, this, it's like, could we run this in Orange Micro, on a Macintosh? What's even going to be more interesting is once Macintosh ports to the PC, then we have no reason not to port to that environment too.
What you said, you were moving it up to the GS standard of General MIDI, so you're going to encompass multiple hashtags as well as the additional controllers.
Yeah, one of the...
You're working with ICS and Intel. Are you guys standardizing on a hash type, a way hash type instead of hash type of controllers embedded in there?
If I had, in terms of the voice, in terms of the controllers and patch type, no. That would be unstandardized because if by voice you mean the actual voice architecture, filter, all that kind of stuff, that will be definitely unstandardized. I want it to be unstandardized. If by voice you mean the GS sound tone map with all of those things laid out, then that's my preference, is to support that as well. I should mention that one of the other early people that are going to be getting it are the game vendors. And they're going to be getting Satie with the editor librarian that we've done. And let's say they don't like, or they don't need the telephone ring in the General MIDI set, or they don't need the bird squeak or whatever, they don't need some of the samples. They can throw out anything they want, put in their own samples, and then they deliver Satie on their CD-ROM. See, now for now, this is it. I mean, if whether you think that the highway is going to be coming into you bits and pieces on CD-ROM, or whether you're actually going to be online, whenever there's a question of whether there's a synthesizer or not at the destination, well, don't worry about it. Just ship Satie down the wire with it, and you're ensured that there's a high-quality synthesizer at your destination. Now, this seems to me to be the exact answer that you need for multimedia. Because even now, you could say, well, I want to send a memo, I want to include a MIDI clip on my memo to somebody over email. Well, you don't know whether they have a Roland GS, you don't know whether they have a GM box, whether they're running in base mode or extended mode. There are 4 different general MIDI targets. And so you're going to say, okay, to read my memo, please take the enclosed MIDI map, and reconfigure your MIDI map, or, it's not going to work.
Apple's been showing a General MIDI software synthesizer for about a year and a half or 2 years now, but they haven't shipped it yet. Do you have any idea of what they're doing?
My understanding was that it wasn't General MIDI. In fact, it was much more limited.
Okay. No, that's not. No, it's.
I think that's going to be shipped with
Yeah. Yeah, they're going to show that. They showed that at ICMC and so forth. That's all fine. This is going to appear on 10 times as many computers.
How good can the product get? It sounds pretty good right now, but you said that the CPU really wasn't a problem. So Penny, why don't we provide margin of improvement?
No, well, the Penny was more than marginal, right? But we have one, and it's pretty astounding. You just anything you throw at us,
Well, is there any, what do you
Well, look, the problem, look, the thing I figured out after getting into all this is that the Intel processor, I hope I'm saying the right thing here, but the Intel processors are pulling far ahead of the ability of the operating system to keep up. I mean, these Windows, all of multimedia Windows is a 0.1, remember? It was Windows 3.0, and then oh yeah, multimedia, 0.1. Okay, that's where we're at right now. When we need to be, at 0.5, at 5, before things start really cooking on this machine. You have the 46 underneath, and not many people know that. I was surprised by this too. 46 underneath it all is essentially a RISC processor. And it's only because it has to run in a stupid 16-bit Windows world that it gets slowed down. So once Chicago comes out, it's just going to, it's with by 432-bit code in there, the stuff is just going to take off like crazy. And they're talking about 90 and 100 megahertz Pentiums now with 3-cycle multiplies that can be pipelined down to 1 cycle. And it could be, yeah, we can do anything with that kind of power. We can do absolutely anything.
So did I understand correctly that the basic sound reproduction method that you're showing is sample playback?
Yes. 2 megabyte sound set with looping. Not all the sounds are looped, of course.
So, and this is 100% owned and controlled by Intel Corporation. So we don't expect to see it on a Power PC very soon.
No, well, yeah, you know, as a business decision, why you want to go after a tenth of the market when you already have 90%?
So you said you could do anything. How about 24 voice physical modeling?
Oh, well, yeah. No, well, yeah, okay, fine. Yeah, I mean, yeah, I can't, you know, Scott's going to show us some stuff that I can't do, presumably. No, but talk to me in 3 years. Talk to me in 3 years. I mean, the P6 has already been announced. This is a 10-fold increase in processing power in less than 2 years. Yeah. So, but we have prepared for that. I don't think I'm breaking any secrets here. Chris Chafe, associated with CCRMA here, technical director for CCRMA, also happens to be associated with SIR, as is Fernando here, another one of our staff. We're close to the advanced technologies, and we're going to be working them in just as soon as we can. You can have my word on that. That's why I prepared this flexible voice architecture where we can plug in different kinds of voices and actually mix synthesis methods dynamically.
So right now, the best sounds are still going to come out of these little black boxes that are not, you know, they're going to be better than a card, a sound card, or your software, or whatever. If you're
generally, I mean, some cards are better than others. I would say you have to listen to any of the cards that are DSP based. They're really, you know, there are 2 types of cards. You have DSP based cards, which in my opinion are really only like maybe 50% better than blasters in a lot of cases. And then you have designer grade sound cards, which are using Ensoniq core.
like the Ensoniq sound module is probably going to be better than getting some sound card, no matter how much you pay for the sound card, right?
Yeah. And plus the other thing about a module is you can, if you need to play with somebody, you need to bring somebody, you have to bring a whole computer. So let's say when you go the Satie route, you know, you just have everything in your laptop. The other route, yeah.
Do you provide some of the special signal processing functions, you know, reverb?
Those that are forthcoming. Those are the things that are in GS that we're going to do. The main difference between GS and GM is reverb, and we're going to be plugging that in. We're working on that now. And the reverb we may not let run on the 46. We have to see exactly how it works. I think the reverb version will be limited to the Pentium.
It sounds like what you're basically saying is you've got something that runs on today's technology, but as the technology goes up the curve, that the architecture that you have can be expanded to cover a lot of the things that you can't do now, but you can, quote, painlessly move into them in the future.
Absolutely. You're dead on. And, you know, the introduction of the P5, P6s are going to be much faster than the introduction of 46. So this stuff is going to be upon us very, very quickly.
Do you require floating point?
No, that's why I say we run on a 46DX or SX, and we run on 386 as well. The reverb mainly is floating.
But was that ADS you do or don't?
Right now we do not use floating point. But that's another interesting situation, because there's an early Pentium and then there's a later Pentium that has a much improved floating point, which gets rid of all the criticisms that Apple was making about it. And that's the one that'll give you the single cycle multiply. And that has a really souped up FPU on it. Okay. Yes, fine.
Remark about General MIDI?
What about General MIDI? I don't know about General MIDI. I just finished a book about General MIDI. I looked at everything thoroughly and I decided it's all screwed up. There are 4 different playback standards, as I mentioned. You have 2 in Windows, base and extended. You have GM, and then you have Roland's GS. And my friends at Roland tell me that now GS in Japan Japan has a market of 300,000 GS users, and that's eclipsing GM now. So it looks like the MMA's indolence is weakening GM considerably. I think that we'll all be onto GS, and that's fine with me. The Roland GS system is very well thought out, and they deserve everything that they get as far as I'm concerned.
Is it downward compatible?
Yeah. The way it works is that Roland has extra banks, and which you can get to using the bank select control or controller 0. And General MIDI, if you set a controller 0 to a general standard device, you get a GM bank. And then you can select other sounds in the set. It's really neat. It's called a fallback mechanism. Where they have this big tree, and then the composer can write for a detailed sound, and if the playback module doesn't have that sound, it jumps back up and plays a more generic version. It's really very cool. And other than that, write to Congressman, because I think it's going to take an act of Congress to get anything more out of the MMA. Okay, thank you very much.
Avram Miller, Vice President of Intel, member of the Board of Directors of AFCO, a friend of music, a generous friend, and he has a remark or two.
I just want to thank Stanley for doing this, and I guess, I don't know how long ago we started talking about this, but this was sort of something I was very interested in, being for music and being a musician, and trying to get Intel to understand music. One of my bigger accomplishments.
It still goes on.
It still goes on. But I think, it's part of a whole trend you'll see, which is trying to make the computer really be primary, preeminent audiovisual device in the home. And it's not just going to be sound, it's going to be vision as well. In fact, right now, on Pentium processors, we're able to do full motion video 3 frames under software. So one of the key things we've been focusing on is making things scalable so they can run on every, flavor of machine. So the software developers would develop applications because there would be a large install base, but that when you have more powerful computers, you could get better things. You could get more frames, better vision, more sound, and so on. And the other thing I think we should all think about is that with this kind of technology that Stanley and this group has developed, let's say that gets on the majority of computers, in 1995. 1995, there'd be over 50 million computers shipped. So think about that, it's 50 million devices capable of playing music. So I don't know what the install base of synthesizers is, but it isn't that, it isn't very big. So what we're doing is going to create a gigantic, a huge market, I think, not only for games, but I hope for all kinds of musical products and for people here who might have ideas. So finally there's going to be some kind of market, because the music market today is quite small. It doesn't really sustain much of an industry. Maybe this will expand it and give people an opportunity to make a living, creating things that are musical. So thanks again, Stanley. And I guess we're going to invite, those who want to come to have dinner with us tonight at the Olive Grove. We're going to have a little dinner and to celebrate this, and Intel will be picking up the tab, so you're all welcome to join. But you should ask now, I guess, right? You need to tell me.
Yeah, I guess, how many are coming up? By the way, for those of you that are new in town or don't get out to El Camino, the address is right here. It's on a MUSIG disk descriptor that has been circulated around. But anyway, there's some more of you if any of you want to know how to get there. It's between the Page Mill Road, which is otherwise known as the Victoria Expressway on the Bayside, and California Avenue on El Camino at 2515 El Camino. But I have to call them and find out tell them how many people are coming. So if we could just have a quick count here. How many people want to go to dinner at 5:30? Hold on there.
Keep your hand up.
Okay, looks like to be about 30 of us.
Wow.
Already?
It's the biggest dinner, music dinner in history.
The specs are cumulative history.
Thank you, Avram, very much.
It's the specs that did it.
So we take a quick break and go right on into the 2 more presentations by Carnal family members here. That's a nice celebration.